Okay, so today we are going to discuss about minimum spanning tree. Minimum spanning tree. So minimum spanning tree होता क्या है? सबसे पहले तो spanning tree होता क्या है? Spanning tree हम किसे कहेंगे? What is a spanning tree? So spanning tree हम किसके लिए निकालते हैं? ये एक basically एक tree ही है. This is a tree, okay, which connects all the vertices. तो ट्री भी एक ग्राफ की तरह है. स्पानिंग ट्री हम किसके लिए डिफाइन करते हैं? फॉर अनडिरेक्टेड ग्राफ. ओके, स्पानिंग ट्री विल बी कैलकुलेटेड फॉर अनडिरेक्टेड ग्राफ. अनडिरेक्टेड ग्राफ. ओके, सो ग्राफ होता क्या है? ग्राफ इज नथिंग बट ए कलेक्शन ऑफ vertices and edges. Okay, so graph is nothing but a collection of vertices and edges. So यहाँ पे V क्या है? This is a set of vertices. This is a set of vertices and edges क्या है? These are the set of edges. Okay. So now if there are two vertices, so these are my vertices. This is my V1 and V2, and they are connected by these edges E1. So this is called graph. This is called graph, and this graph has two vertices and one edges. So this graph has two vertices and one edges. Okay, so now graph can be two types. Graph can be two types. So what are these? One are directed graph. Directed graph. Another one is undirected graph. Okay, so what is directed graph? Means there will be some direction will be given. There will be some direction will be given, and in undirected graph there will be no direction. Okay, so spanning tree होता क्या है? Spanning tree हम निकालते हैं किसके लिए? ग्राफ के लिए, अनडिरेक्टेड ग्राफ के लिए. ओके, सो स्पानिंग ट्री ऑफ ए अनडिरेक्टेड ग्राफ इज नथिंग बट ए subgraph. Okay, so this is a connected subgraph which contains all the vertices and they have no circles. Okay, so spanning tree क्या है? So spanning tree of an undirected graph is a connected subgraph okay, which contains all the vertices and there no circle. There is no circle. Okay, मान लो कोई ग्राफ दिया गया है. Suppose this is a graph and they have some four vertices. This is V1, this is V2, V3 and V4, and these vertices are connected. All the vertices are connected. Okay, so this is my undirected graph. This is my undirected, and all the vertices are connected here. So this can be called connected undirected graph. Okay, तो कोई भी कनेक्टेड अनडिरेक्टेड ग्राफ का आप स्पानिंग ट्री निकाल सकते हो. कैसे निकालते हैं? स्पानिंग ट्री होता क्या है? वो भी एक कनेक्टेड सब ग्राफ है जिसमें हर एक वर्टिसेस होंगे जो गिवन ग्राफ होगा. ओके, एंड देयर विल बी नो सर्कल्स. मान लो यहाँ पे कितने वर्टिसेस है? V1, V2, V3, V4. Okay, so there will be four vertices: V1, V2, V3 and V4. Okay, and you have to connect all the vertices, and there will be no circles will be there. Okay, so here this is my connected graph. This is a connected graph. this is a connected undirected graph. Okay, and this is my subgraph of this given graph. Okay, so this graph can be called as spanning tree. Spanning tree. Okay, so this is spanning tree of my undirected graph. Undirected graph. Okay, since there is no circles are there. Okay, similarly I can create a spanning tree using these four vertices, like this. So you can create a spanning tree like this. Okay, so there is no circles here, and I am also using four vertices, and four vertices are connected here, and there is no circles. So this this connected subgraph is also a spanning tree. Okay, so this is also a spanning tree. So similarly, you can create many numbers of spanning tree from a given graph. Okay, so you should be maintained. You should be careful that there should be no circles will be there. So using these four vertices, you can also create it like this. So here, so this will be my also spanning tree. Spanning tree. Okay. Now you have understood what is spanning tree. So spanning tree क्या है? Spanning tree एक tree है और एक connected subgraph है जिसके अंदर हर एक vertices होंगे पर कोई भी circles नहीं होगा. हर एक vertices connected होगा edges से, but there will be no circles. So if there will be n vertices, then how many edges will be there in spanning tree? There will be n minus 1. N minus 1 edges will be there. If there are n number of vertices. If there are n number of vertices is given, then you can create a spanning tree and there will be n minus 1 edges. Okay, and there will be no circles. Now, what is minimum spanning tree? Minimum spanning tree हम किसे कहेंगे? Minimum spanning tree किसे कहेंगे? What is a minimum spanning tree? So what is a minimum spanning tree? So minimum spanning tree हम किसके लिए निकालते हैं? Weighted connected graph के लिए. Okay, so minimum spanning tree is defined for a weighted connected graph. Okay, weighted connected graph means there will be some weight on the edges. Okay, so there will be some weight on the edges. समझो? So minimum spanning tree of a weighted connected graph is a spanning tree. Is a spanning tree. Is a spanning tree with minimum weight. With minimum weight. Okay, so मान लो this is a given graph and every edges have some weight. Suppose this is a graph. Okay, now every edges, suppose these edges have some weight. Okay, so let's suppose this is 5, this is 10, this is 3, and this is 7, and this is 8, and this is 4. So every edges have some weight here. Okay. Now from this you have to create a minimum spanning tree. How can you create a minimum spanning tree? So in minimum spanning tree you have to use all the vertices. You have to use all the vertices and there should be minimum weight. There should be minimum weight in the spanning tree. Okay. तो इससे आप इस ग्राफ से आप किस तरह की स्पैनिंग ट्री बना सकते हो? आप या तो यहाँ ये. So this is my spanning tree. But what is the weight of this spanning tree? So this is 5, this is 3, this is 7. Okay. So what is the total weight here? What is the total weight here? So this will be 5 plus 3, 8. Okay, so this is 15. Okay, so similarly you can also create a minimum spanning tree. Is this a minimum spanning tree or not? So let's suppose this is also a given spanning tree and I am connected using these edges. Okay, and these edges have weight 10 and this is 7, this is 3. So now what is the weight of this spanning tree? So total weight is here 20. Okay, so in between these two spanning tree, this is my minimum spanning tree. This is my minimum spanning tree. Okay, because this tree have the minimum weight compared to this spanning tree. So both are my spanning tree, but this spanning tree is my minimum. Okay. Now, how can you create a spanning tree? How can you create a minimum spanning tree? अब कैसे बनाओगे minimum spanning tree? So there will be some algorithm. You can use those algorithm to create a minimum spanning tree. Okay, so those algorithms are called, one algorithm is called Prim's algorithm. Okay, so one algorithm, using this Prim's algorithm, you can create a minimum spanning tree. You can create a minimum spanning tree. So another one is called Kruskal algorithm. Kruskal's algorithm. Okay, so using these two algorithm, you can find a minimum spanning tree. Minimum spanning tree. So now, what is Prim's algorithm? What is Prim's algorithm? Let's discuss the Prim's algorithm first. Okay. So let's before telling you the pseudocode of this Prim's algorithm, let's discuss using some example. Okay. Suppose there will be some connected graph is given. Let's suppose this is my graph, and this graph have some weight. Also, every vertices, let's see, this vertices is 1, this is 2, okay, and suppose this is 3, this is 4, and these are connected. Okay, let's take another vertices 5. Let's take here 6 vertices, and it is connected to here, and this is also connected. Let's take another vertices 7. Okay, and they are connected here, and these edges have some weight. Let's suppose this is 25, this is 14, this is 11, this is 17. Let's suppose this is 12, and this is suppose 20. Let's take this is 22, this is 23, and this is 10. Okay, so this graph is given, and they have asked you to find the minimum spanning tree. Find minimum spanning tree. Minimum spanning tree using Prim's algorithm. Okay. So you have to create a minimum spanning tree. So in minimum spanning tree, there should be minimum weight. Okay. So here every edges have some weight. So you to create a spanning tree, you need to take all the vertices of the given graph. So let's take first all the vertices, then we will try to create a spanning tree. Okay, then we will going to select an edge with minimum weight. Okay, so first draw all the vertices, or take all the vertices, take all the vertices first. Okay, so let first draw these vertices. 1, this is 2, this is 3, this is 4, 5, 6, this is 7. Okay, so before just draw these vertices, then what you will going to do, you will select an edges with minimum weight. Okay, select an edge with minimum weight. Okay, so by selecting adjacent edges with minimum weight, so you have to select a minimum edges, but be careful, do not create any circle, okay. So what is a given graph here? So this is your given graph and every edges have some weight. So in between, so let's start from this vertices 1. Okay, so here when I am taking all the vertices, there is no edges. So in this there is no edges. So since there is no edges, what is the total weight here? Total weight is 0. So total weight is 0. Okay, so this will be your step 1. Okay, now in step 2, select an edge with minimum weight. So what is your minimum weight here? So if you are starting from this vertices 1, so in vertices there are 2 edges are connected. One is your 25 and another one is have weight 10. So in between these 2 edges, 10 is my minimum. So connect these 2 vertices with weight 10. Okay, so now your total weight is of this graph is 10. Okay, so here you are connected to 6. Okay, so now in from 6 there is only one edges, that is 23. So you have to connect this 6 vertex with 5. So this edges have weight 23. Okay, so now what is your total weight? So 10 plus 23, this is your 33. Okay, so now you have connected up to this vertices, then you will connect it to 4 vertices. So 4 vertices have only to connect these 4 vertices from the vertices 5. There is only one edges, that have weight 20. Okay, so now total weight of this graph is what? So 33 plus 20. So now it becomes 53. Okay, then you are going to connect 4 with 3. So there is this edges, this is an edges, and edges have weight 11. So now what is your total weight of this graph? So 53 plus 11. So this will become 64. This will become 64. Okay. So now again you have to connect 3 to 2. So you have to connect all the vertices, but be careful, there will be no circles. Okay, so now we are going to connect 3 with 2 and these edges have weight 14. So now you have to add 64 with 14. So this will be what? 78. So total weight of this graph is now 78. So now we are going to connect 2 with vertices 7. Okay, so this vertices have how many weight? This is 12. So now we are going to add this 12 here. So now total weight of this graph is, this is 90. Okay, so total weight here is 90. Okay, so now here I am creating a spanning tree. Okay, and this spanning tree have minimum weight, and this is called minimum spanning tree with weight 90. Okay, understood? So you have to select a minimum weight. Okay, so first step is take all the vertices. Okay, then select an edge with the minimum weight, then just proceed and connect all the vertices. Okay, but you should not take any circle. You should not form any circle. Okay, so this is, now we have to create a minimum spanning tree here. Okay, so similarly, let's take another example. So suppose there is some given graph is given. Okay, now you have to generate a minimum spanning tree using Prim's algorithm. Okay, suppose this is my vertices 1, this is 2, and they are connected with an edges have weight, suppose 10, and this 2 is connected with 3. Okay, and they have suppose weight 28, and 3 is connected with vertices 4, and they have weight some 16, and suppose there is another vertices 5th, and this is connected with 3, and they have weight suppose 14. Okay, and 5 is connected with another vertices 6, they have weight 24, this is connected with 7, weight 22, these are connected, this is 18, this is 12, and suppose this is 25. Okay, so this is a given connected graph. This is a given connected graph, and every edges have some weight. So now you have to generate, or you have to find the minimum spanning tree using the Prim's algorithm. Okay, so first what you are going to do, just take all the vertices. Okay, so now take all the vertices 1, 2, 3, this is 4, here is 5, this is 6, this is 7. Okay, now you have to select a minimum edge, minimum weight. Okay, so there is only these edges, so you have to connect all the vertices and do not form any circles. Okay, so now 1, 2 can be connected with these edges. This is my vertices, weight is 10. Okay, similarly here you can connect 1 with 6, these are weight 25. Okay, so from this you can connect here, so this will be 22. Okay, from this you can connect with 4, this is weight 12, and these are connected here, this is 16, and here you are going to connect with 5, so this will be 14. So now this becomes your minimum spanning tree. Okay, now total weight is what? Total weight of this minimum spanning tree is, so this is 10 plus 25 plus 22 plus 12 plus 16 plus 14. So 16 plus 14 is 30. 30 plus 10 is 40. 40 and 20, this is 60. 60, 20, 80. 80, 10, 90. 90, this will be 95, 97, and this is 99. So total weight of this minimum spanning tree is what? 19. Okay. So you have to select an edge and just connect all the vertices, selecting the adjacent edges with minimum weight. Do not form any circle. Okay. So this is your Prim's algorithm. This is your Prim's algorithm. So let me write the algorithm for the Prim's algorithm. Okay, so here I am going to write the algorithm. So this is Prim's algorithm. Okay, so here you are going to take a function. Suppose the name is Prim, and it will take some graph of, they have some size. Okay, they have some size and they have some node. Okay, so you are going to take some node here and the graph here. Okay, so using this Prim's algorithm, you are going to generate a minimum spanning tree, or you are going to find the minimum spanning tree. So there will be some input. So what will be the input of this? So this will be, there will be given a weighted graph. Weighted graph. And the total numbers of node. Total numbers of node. Okay, and on the output you have to create a minimum spanning tree, MST. In a short form it is called MST. Okay, so first what we are going to do, initialize the selected vertices list. Okay, initialize the selected vertices list. Okay, so now we are going to run a for loop. Assign this with initialized value is 0, and you are going to connect up to n minus 1 nodes. Okay, n minus 1 nodes. So now suppose in this tree of I, initialize this to 0. Okay, then in tree of 0 node initialize to 1. That means what? Take the initial vertices. ओके, तो यहाँ पे आपने सिर्फ एक वर्टिसेस को यहाँ पे लिया है, एक इनिशियल वर्टिसेस or the initial vertex. Okay, so here from this you are going to find the minimum edges. Okay, so let run another loop. So suppose this variable k is initialized to 1. Okay, and it will be running up to n. Okay, so you are going to select a minimum weight, minimum distance or minimum weight. Okay, so initialize this is to, suppose there is no edges is there, so initialize this is to infinite. Okay, so initially assign minimum distance as a infinity. Okay, so initialize this is to minimum weight or minimum distance is infinity. Initialize to infinity. Okay, so after that you have to run another for loop, and it will be going to run from 0 to n minus 1, and in this for loop there will be nested for loop, Okay, so here in this nested for loop, you are going to select the edges. Okay, so you are going to select the edges. So suppose this for loop variable j, it is initialized to 0, it will run up to the n minus 1 vertices. Okay, so what you are going to do, select an edge such that one vertex is selected and other is not. Okay, and they have least weight, so you have to write like this. You have to check the condition. If g graph and this graph and you have a tree of I and tree of j, okay, or there will be no tree. If there will be no tree, okay, and there will be tree of j. So put this into the bracket. Put this into the bracket here. Okay, so these are brackets. Okay, if this condition is true, means here you are going to select the minimum or least weight. Okay, so here you are going to check whether your graph or vertices have the minimum less than the minimum distance. Okay, if it is assign obtain that edge with minimum weight. Okay, if it is less than the minimum distance. So initialize हमने क्या किया था infinity से. So अगर इसका weight इससे कम है तो आप क्या करो, इसको minimum distance के हिसाब से assign कर लो. So minimum distance will be g of ij. Okay, then picking up those vertices. So pick that vertices v1 equal to I, v2 equal to j. So take these vertices like this. So we are going to keep picking the vertices with the minimum edges. Okay. So now just close the bracket here. And after that you have to write v1, v2 and with the minimum distance. Okay, so this will now next will be tree of v1 and this will be assigned to tree of v2 and initialize this is to 1. Okay, so now your total weight will be initially we are initialized to total is 0 and you are going to add this minimum weight here, minimum weight of the minimum distance. Okay, so after that if you are keep doing this you will get the total weight of the spanning tree. Okay, or here will be total length or total path length. Total path length is, this will be total. Okay, so this will print the total path length or total weight. Total path length or total weight of your minimum spanning tree. So this is your Prim algorithm. Okay, so whatever we have discussed before, using this example, okay, you are going to find the minimum spanning tree. So they will give a weighted connected graph and First you have to select all the vertices. Okay, so you have to select all the vertices, or you can select first vertices, initial vertices, then you have to connect that vertices with the adjacent vertices with the minimum weight, okay. Then you are going to repeat those steps, and you are going to connect all the vertices, and be careful, do not create any circles, so after that you will get a minimum spanning tree with the minimum weight. So this is nothing but a Prim's algorithm. Okay,